This video is going to cover chapter 7, part B, which is about how to make grammatically correct, if you will, compound statements. In other words, how to construct well-formed formulas. So there are 4 basic rules that govern whether or not a formula is well-formed. That is, whether the compound statement is grammatically correct. We're going to walk through each one of them. So the first rule is that the dot, the wedge, the horseshoe, and the triple bar symbols must go between 2 statements. And the statements that they go between can either be simple statements represented by a single capital letter, or other compound statements, which are contained within parentheses. Now, this is an important note. You often see parentheses in compound statements. The contents of a set of parentheses are a single compound statement within a bigger compound statement. So you should treat each set of parentheses as if it's one statement. And so logical operators will range over an entire compound statement that is contained within a parentheses. All right, now with that said, let's go back to rule 1. So here are some examples of well-formed formulas. In this one, you've got if P or Q, then not R. Now this is a well-formed formula because the horseshoe goes between 2 statements. The statement it goes between is 2 other compound statements. First of all, you've got not R, that's a compound statement. And then you've got P or Q, that's a compound statement. So the horseshoe checks out. The wedge also is between 2 statements. In this case, they're 2 simple statements, P and Q. So that one checks out fine. So does this one. The dot is between S and P. This other dot is between Q and S. And the wedge is between 2 compound statements, S and P and Q and S, contained in parentheses. Now let's look at some examples of how things can go wrong. Look at this one, dot P. What's the problem? Well, the problem is that there's no other statement on the left-hand side of this dot. You can't have a dot. It's like saying and P. Like what and P? It doesn't make any sense. Here's another problem, PQ wedge. Now the problem here, one problem is that there's nothing on the right-hand side of the wedge, so it breaks the rule. Also, there's a problem with just having PQ and nothing in between them, but I'll say more about that in a second. And then here's the horseshoe, horseshoe P. That's like saying if what, then P. I don't know. And the same over here, you've got Q, if and only if, nothing. So none of those check out. Now, let me give you a Sasser's corollary to rule 1, and this is important, I think. Just as you can't, these 4 symbols must go between 2 statements, so also you can't have 2 immediately adjacent statements without having one of those 4 symbols between them. Statements in a well-formed formula have to have defined logical relationships. And if they don't have a logical operator between them, they need to have a define the relationship conversation. So you can't have P, Q. What are they to each other? Are they a conjunction? Are they a disjunction? Are they conditional? Are they it's complicated? We don't know. So you've got to have something between them. Or you can't have P parentheses Q or R. Again, what's the relationship between P and the parentheses statement? We don't know. Put something between them. Define the relationship. Okay, the next 3 rules. Rule number 2, the tilde goes in front, that is to the left of the statement that it is meant to negate. So in this one, you've got tilde, parentheses, P or Q. That means that the tilde is ranging over, it's negating the parentheses. It's not the case that P or Q. And actually what the whole compound statement says is this. If it's not the case that P or Q, then not R. That's what that says. So this tilde range is just over the R because it's the one it's in front of. Similar over here. Now here's how things can go wrong. You can't have P tilde. Tilde what? What's it negating? It's not negating the P because it's on the wrong side of that P. It's negating the void. Similarly, you can't have parentheses P or Q tilde. Again, what is this tilde negating? We don't know. Nothing. The abyss. How about this one? Tilde, parentheses, S and P, tilde. It's kind of an attractive aesthetic symmetry, but logically it's a disaster. Not quite a disaster. This tilde makes sense. The first one, because it negates the parentheses. It's not the case that both S and P. But this second tilde, again, is negating the void. It makes no sense. Okay, so the tilde's got to go in front to the left of the statement it's meant to negate. Rule number 3, the tilde cannot by itself go between two statements. Now, it can go between a logical operator and a statement, like here, P or not Q. That's fine. Here's what you can't have, P tilde Q. Because here's the problem. We have an undefined relationship between P and between the compound statement, not Q. What's the relationship between them? We don't know. So go back to Sasser's corollary. And then finally, rule number 4, parentheses, brackets, and braces are required in order to eliminate ambiguity in a complex statement. So for example, this is all nice and purple, P or Q and R, even all this checks out just fine. But here's where you go wrong. P or Q, parentheses, and R. There's a lot of problems here. First of all, what's the relationship between Q and the parentheses compound statement? We don't know. Secondly, this compound statement inside the parentheses breaks rule 1. It's like what and R? We don't know. So that's all messed up. Let me give you what I think is a better way of understanding rule 4. I think the way they state rule 4 here is a little bit ambiguous. It doesn't tell you really, well, how do I eliminate ambiguity? Here's the issue. Here's the tip. You can't have 2 of these 4 symbols, that is horseshoe, conjunction, wedge, triple bar. You can't have any of those 4. You can't have 2 of them in a row unless you have parentheses between them to eliminate ambiguity. For example, you can't have this. You can't have P and R or S. Why? Because we don't know whether you mean P and R or S, or whether you mean P and R or S. Those are 2 different things. We need parentheses around one of those pairs in order to eliminate the ambiguity. There should be at least one logical operator. So you either want to put the parentheses around before the P and after the R, or before the R and after the S. Also, there should always be at least one logical operator outside of the parentheses. You're never going to have a situation where the parentheses are around the entire compound statement. There's going to be some logical operator outside of them. Otherwise, you wouldn't need the parentheses. So those are my tips on rule 4. Let's do a couple examples here. Let's see, are these well-formed formulas? Has something gone wrong? And if so, what? Check out A here. Bracket S or Q and not P, and all that is antecedent. If all that, then not R. Does that check out? Yeah, that one's actually good. That all is fine. That obeys all the rules. How about B? It's not the case that either if S then R or Q and P. Yeah, that checks out too. That's actually fine. You can obey all the rules. What about parentheses R and S or P, close parentheses? Well, that's a hot mess. Here's the problem. You got a couple of problems. It mainly breaks rule 4. These parentheses don't, first of all, there's no logical operator outside the parentheses, so they're not doing any good. That's like Sasser's tips, right? You always are going to have a logical operator outside the parentheses. Furthermore, inside those parentheses, there's ambiguity. Again, you've got a conjunction and a disjunction without any parentheses between them, which, look back at my tips. As I say, that's what you can't have. You've either got to take this parentheses and put it after the not S, or take this parentheses and put it before the not S. Okay, what about D? Parentheses, P, tilde, close parentheses, and either not S or if R, then Q, parentheses, bracket. The problem here is the stuff inside parentheses. First of all, you don't need these parentheses. They're not really doing any work, so you could drop them. Secondly, this tilde isn't before any statement. So it's like negating the abyss. So it breaks rule number 1. What would make sense is if you had like tilde P and all that, then you'd be good to go. So I leave you to practice this further on your homework.